Hello everyone and welcome to yet another Azuzin session. So today we continue developing the search engine in Rust that we started to develop some time ago. You can find the source code of this thing in the description if you're interested, right? So it's going to be there. And let's take a look at this thing. So this is basically a very simple local search engine. So the entire idea was born when I needed to search locally the OpenGL documentation. So what I decided to do, I decided to implement this simple project that uses TF-IDF, term frequency, inverse document frequency, to search within the documents, and it works reasonably well. Actually, it works reasonably well. So let's take a look at it. So the first thing you have to do, you have to index the folder, right? So let's run with release, of course, right? Otherwise it's going to be too slow because it's Rust. And let's say that we want to index this entire thing, and there we go. It's going to recursively go through all of these folders. But first it needs to compile all of that, of course. We are compiling with the release that enables a lot of the optimizations. And then it recursively goes through all of the files in there and just indexes them, and it creates a index.json, right? 2 megabytes, actually almost 3 megabytes JSON. And the next thing you have to do, you have to serve that specific index.json, and doing so, and not search, serve. And doing so will start up the local HTTP server. You go there, right? You go there, and you greet it with this very simplistic UI, but this is because we didn't spend any time improving it. And now you can search within the OpenGL documentation, right? So we can say linear interpolation, my favorite query that I use all the time. And as you can see, it finds things that are related to linear interpolations. So it uses TF-IDF to rank the documents according to their relevancy to the prompt, right? So then we can do something like find something about like binding frame buffer, right? So anything related to binding the frame buffer, and it literally found the function gl bind frame buffer, right? So it uses the how often certain terms occur in the documents, and it just ranks all of that accordingly. If you're interested how that works, you can Google up TF-IDF, right? It's a very old technique that is used in information retrieval, and it's also a very simple one, and also a very effective one, actually. It works relatively great. Right, TF-IDF. So today I wanted to improve the user experience a little bit, right? So because as you noticed, what you have to do, you have to call separate subcommands. First you have to index the folder, and then you have to serve it. It would be kind of nice if you just had one command: serve the folder, and all of that indexing and stuff like that is going to happen behind the scenes, right? So my idea was the following. I start serving the folder, right? The search engine effectively goes through all of the files in a separate thread and indexes them, and while it's doing all of that, I still can use this website in here, right? Obviously, when it didn't finish indexing, it's not all of the information is going to be available, but I want to be able to search within the information that is already indexed, even though it's not full, right? So yeah, and that way I think it's going to be easier to use, because the only thing you'll have to do, you'll just have to start this entire thing on a very specific folder, right? So I want to search within that specific folder, don't want to do anything else. I just like open up the website and start searching, and maybe whatever I want to search is going to be already in the index, and it's going to continue keep indexing in the background, right? So let's go ahead and implement that, right? Let's go ahead and implement it. We're going to be using the regular threading primitives of Rust. We're not going to use any third-party dependency or any like third-party frameworks. Whatever we have already in a standard library, we're going to use that. Maybe it's not going to be super optimal, but I just want to have some sort of like a job running in the background. So the problem here could be with the fact that right now, if you serve, it will reindex everything, right? So every time you run the index command, it just basically reindexes everything, regardless whether we already indexed that or whether something new was added. It just doesn't matter. It always reindexes everything. So what I was thinking I want to add first, I want to add an ability to check whether a certain file was already indexed or not. So the way we can do that, we can use the regular technique that is used, for example, by makefiles, right? Essentially, makefile will look at the date of the last modification of the file, and if the date is fresher than the date of modification of makefile itself, only then it will try to rebuild the corresponding target. So we can do something similar, right? We can store the date of last modification of the file that we indexed, right? And then if that date changes on the next run, we know that we need to reindex that specific file, right? Or something like that. Maybe it's going to be slightly different. Maybe as I implement this, I think I will discover that that's not a particularly good approach, but we need something that prevents us constantly re-indexing the same thing over and over again, because we don't have the separate index subcommand. Now it's the same thing. So in the first approximation is going to be basically keeping track of the last modification date of the file. So let me see how we can do all of that. I'm going to find my model, right? So this is going to be in-memory model. And what we have in here, we have documents, all of the documents, and each document contains the hash table of the terms, how frequently certain terms occur within the document, and a count, if I remember correctly, this is how many terms are within the document or something like that. I don't quite remember. I think yeah. So because we need to be able to know the relative amount of terms within the document. Usually we'll just take a value from this hash table and divide it by the whole thing, and thus we're gonna get a ratio of this specific term within that specific document. Right, so here we can just basically store an information about like last modification or something like that. Last modified. Right. Last modified. And I know almost nothing about how represent dates and time in Rust, so this is something that I will have to research real quick. So I'm going to do Rust up, and I probably have to do that without ampersand, because otherwise it doesn't work. So let's open API, and I'm going to literally just search for time, right? Anything related to time. There is std time. Look at that. So is there any date? Maybe this is what I have to search for. Do you have date? You don't have date, you only have time. Okay, maybe it's covered entirely by time. So what do we have in here? We have different structures, right? So there is a system time. Maybe that's exactly what we need. A measurement of the system clock useful for talking to external entities like file system or other processes. Okay, that's basically what we have in here. And we can know the current time. So maybe this is something that I want to actually check out. So let me go to main.rs and essentially create a new subcommand. Let's go ahead and create a new subcommand called now. And I'm going to literally try to do something like this. I'm going to do println now, and now is equal to system time now, right? System time is located in std time, excuse me, system time, system time. All right, and let's actually try to run now and see. Okay, so it doesn't like that I don't return things in here. System time is not formattable with the default formatter. Okay, so it is true, as we can already see. Right, it uses the debug formatting. Okay, so I'm going to put it in here. What else do you want? It probably wants me to remove this thing, and we're good to go. Look at that. So this is the system time. It suspiciously look like the thing from POSIX. I remember, yeah, if I do man clock get time, yeah, so there is a time spec structure, the definition of which contains two fields, tvsec and tvnsec. And that is kind of sus that, yeah, look at that. It's literally the time spec from POSIX. But I mean, it's probably, it could be different depending on the platform we're talking about, right? So if we take a look at this thing, I already in here. So let's take a look at the source code. Yeah, time, system time. So it's just a structure, and I suppose depending on the specific platform, it's gonna be implemented differently. Yeah. It's probably not worth looking into all of that because it's just like too many things in here, but yeah. Oh, okay, so we even have some sort of a table in here. Just a second. It's a little bit difficult for me to control this entire thing because my wheel in the mouse broke and I can't just scroll anymore. And sometimes to scroll, I have to use my touchpad on my laptop, right? So yeah, there we go. So we can clearly see that on Unix it uses clock get time, as already noticed, and on Windows it uses get system time precise as file time, and because of that the representation on Windows could be different, right? It's just something interesting to point out, I think. All right, so let me see. So we're gonna be storing this kind of stuff in there, and because of that, by the way, I feel like it might be not cross-platform in that sense. That's very interesting. So yeah, because we're dumping the index in a file system, and then that specific index might not be compatible with Windows version of this entire thing, right? So if you recompile the entire code on Windows, it might not actually work. This is something to investigate in the future, right? I think. Anyway, so let me actually try to compile this entire thing and see if it's going to work. Well, I mean, I will have to include this kind of thing somewhere. Use std time, system time, right, of course. Default, and system doesn't have a default, right? Okay, so that's very interesting, right? That is very, very interesting. I wonder if there is a way to serialize this entire thing. So we're using serde. I wonder if there is a conventional way of working with system time and serde, right? Serde system time. Let's Google that. System time and serde. Okay, serde lib do. All right, a measurement of the time. So I suppose serde just by default supports all of that. The main problem here is with the default thing. Right, and what do we use default for? Let's actually go ahead and remove default and see where exactly we use all that stuff. Missing last modified, okay. So when I'm inserting, oh, that's cool. So we're adding a document, right? So we provide the file path, and then the content of that specific file path, and we just do that, but we don't have an information of the when was that file specifically last modified. We just literally don't have that information in there. So I wonder if it is located somewhere in the path buffer. Probably not, but who knows, maybe it's just like available there. System time, so, or maybe just time. It is not available there. All right, but I'm pretty sure it's available in a place where we call this entire thing. So I can just do something like last modified, and I'm going to say, okay, so this is a system time, and then I'm going to put the last modified in here and try to recompile. It should fail in a place where we call all of that stuff. So what you don't like in here, method add has 4 parameters. Oh, the problem here is that add document is part of the interface. Right, so it is part of the interface. So here we do that, but this is just in implementation. Where is the interface? Trait model. So last modified system time. Okay. So, and yeah, so there's a SQLite model. I don't really use SQLite model anymore. Maybe at some point I'm gonna actually remove it, but I just keep it in here just in case. Okay, so this is where we call all of that, right? So this is the add folder to the model. It's a recursive function, right, that calls to itself, and it is using file entries. Okay, so there is a directory, there is a file entry, So let me see what we have in here. We have to find read dir and see what it returns. Right. It returns read dir entries, and each read dir entry should have a lot of perks that we can look into. Right. So every time we do next, we have dir entry. So this is very interesting thing. Right. So we have a path. Right. So we extracting the path. We can clearly see that. Right, so this is the file path, and the file path is taken from, let's find out, where is it? It's taken from here. So maybe we're going to have something like last modified, similar to that, and this is going to be from file. Let's find the corresponding function that is capable of doing that. So there is a metadata, which is nice. Let's take a look at what metadata is capable of. Right, so does it have anything interesting in there? So is it symlink? We have a length, we have permissions, modified, and it's precisely system time. Would you look at that? That's precisely what we need in here. Isn't that amazing? I think it's goddamn amazing. Oh my god. Okay, so we can do something like file modified. And this entire thing may actually return results. So path doesn't really return. If we take a look at the path, where is the, well, I mean, it's not part of the metadata. So yeah, okay, this one is rather interesting. So we first have to take the metadata, right, metadata, and I'm pretty sure we already get it from somewhere, do we? So this is a file type. Okay, file type is separate thing in here. Okay, so I suppose what we have to do, last modified, is there maybe modified in, nah, we have to take metadata. Last modified file, metadata, and it can fail actually. That's what's interesting. So we have to log that specific error. Right, ePrintLN error could not determine, not really determine, get the metadata of file path, right? Specifically file path, and then we're gonna print the error y. We're gonna get that. But specifically here, we also have to do file path display, right? So we have to display this entire thing, and there we go. But on top of that, that's the problem, right? Once we got the metadata, right, modified, modification, right, modified, it's another result, right? So that means you have to do that twice, right? Which is kind of weird, but I guess it's fine, right? So, modified, modified, map error, ePrintLN. So maybe we have to actually unwrap this entire thing in here, right? So then in here we're gonna do error could not get the last modification date of file path because of the error reason. There we go. And file path is of course file path display. There we go. Right, and here we just do that. So we have to do that in a very interesting way, as you can see. Maybe we could sort of collapse all of that, but at the same time, maybe it makes sense to separate like different kinds of login in here. I'm gonna leave it as it is right now, and we'll see how it goes. And when we add the document, we also have to provide the last modification date, and that should be it basically. So let's try to rebuild this entire thing. It rebuilt successfully. Okay, so let's do cargo run index, and this is going to be docs.jl, and of course let's actually do that in release and see how the representation, the internal representation, is going to change. It's really interesting. So because I'm really curious how Surdis stores the system time. Okay. So it's done. Let's actually do the following thing where I'm going to take JQ, then index JSON, right, and I'm going to actually say dot. I keep forgetting how you do that actually. Is that the dot comes first? Yeah, the dot comes first. Okay, so I'm gonna save that into index pretty JSON. Hopefully that will work. Okay, so that worked successfully, more or less. And let's open this file. Okay, so for a single document, so this is the first document, we have term frequency, and then the count, and last modified is this thing. So sex since epoch and nanos since epoch, and I wonder if it's going to work on Windows. So that's a very interesting question, right? Because it's still using representation of the of POSIX, right? So does it adapt this somehow to Windows? So I'm not sure if I want to go into that right now. So maybe I'm gonna just like check it out later, right? So I'm gonna put it to do. Right, so this is going to be docs, struct doc. Make sure that the serialization of system time also works on other platforms, right? So maybe I'm going to actually put this thing in here because it's kind of like it may break. I can see how it can break. So we have to be really careful with that. In any case, what I want to do now, right, what I want to do now is essentially just check that this file already exists in the model. If it doesn't exist, we want to add that file, right. If it does exist, we need to check its modification, last modification date. So maybe it makes sense to do that within the add document file itself, right? Because this is where we can have an access to the last modification date. So let's actually see. So add document. All right, that's pretty cool. Docs insert, and this specific thing is rather interesting. It is rather interesting. It assumes that the file does not exist because, as you can see, we're literally just inserting it. You would literally just insert it in the case when you know that it doesn't exist there. But now we're like the invariant has changed. Now it can exist there, right? It can actually exist there because we are reindexing and stuff like that. So I suppose the first thing we have to do, we have to retrieve that document from the model itself, right? So we want to do something like self-docs get mutable, right? So this is going to be a mutable document. Maybe we have to do something like this. If let some doc, right, we get the mutable document via the file path, right? Maybe we also have to put the reference in here, right? And we're going to have two situations when we found the file, right? When we found the file and when we didn't find the file. In case of when we didn't find the file, we can just do whatever we were doing before, right? So simply do whatever the hell you were doing before and insert it as usual. So there's nothing wrong with that. If it does exist, so we want to check its last modification date. So we can just access it like that. And the question is, can we compare it, right? I suppose we want to sort of, how to say that, reindex only if the last modification date is greater than the last modification, actually smaller than the current last modification. So this is an actual one, right? This is the actual last modification, and this is what would whatever have in the model, right? So in that case, we want to reindex this entire thing, right? We want to reindex this entire thing. So I'm going to do something like to do reindex, but I'm not sure if you can just compare system times like that. So let's take a look. I'm going to take a look at the system time. Does it implement like ORD interface, right? ORD. Let's take a look. It does implement. Okay, that's cool. So let me just try to compile this entire thing without running it. Simply compile it. Okay, so what we have in here. Else close if maybe blah blah blah. Excuse me. Maybe missing else clause. Why? Oh, this is because you're supposed to return something. Yeah, I see. Well, I mean, in this specific case, we can just like share a single OK for both of the branches, because why not? Okay, that's cool. So the problem here is that we need to repeat this whole body in case of this condition. I mean, I can just copy paste it, but it's not particularly great. And on top of that, you know, copy pasting it is not a great idea, because we need to replace whatever we had in there, right? We need to replace whatever we had in there. So insert, as far as I know, it replaces the things, right? So if I take a look at hash map, right, so, and should have actually searched straight up for insert, but whatever. Yeah, as you can see, it literally returns whatever we had before. Insert a key value pair into the map. If the map did not have this key present, none is returned. If the map did have this present, the value is updated and the old value is returned. Okay, that's pretty cool. So what would be the best way to actually do all of that? Because just by inserting, we simply replace whatever we had before, right? We simply replace whatever we had before, and that's totally fine. Also, interestingly, so we also have document frequency, right? Document frequency. So this one also probably requires updating. Let me find the model. So document frequency, and document frequency is a map from a string. Okay, so yeah, this one is rather interesting, because essentially this is a map from a term to in how many documents that term exists. So if we re-index in the document, we invalidating not only the specific doc in here, we're also invalidating a lot of stuff in here. Right. So essentially, I have a feeling that we need some sort of a special operation similar to add document. Right. So we have add document, but we need a similar one that says remove document. Right. Remove document. And it's probably going to only accept file path. So, and what I would expect from such thing, I would expect it to simply first remove it from the doc, and then go through the document frequencies and remove, like, do -1 for like each term that you encountered in here or something like that. Right, so I think that's one thing that we want to have in here, right? That's one of the things we want to have in here. So this one is, of course, is not implemented, right? So this is to do. I'm going to just put like this, whatever. So an add, well, this one is rather interesting. I suppose add is going to be simply just this, what it was before, right? So this is going to be, excuse me, add. And then we're going to have the logic of checking of last modified date somewhere in replace, if you know what I mean, right? Somewhere in replace, but I'm not sure how good of an idea that is. Though, all right, maybe it's for the, yeah, I'm not sure, maybe not. Let's actually leave it as it is. All right, let's actually leave it as it is. So what I'm thinking is that what we want to do, we may want to do the following thing. So if the document is already there and its last modified is greater or equal to the actual thing, right? It's probably never going to be greater. It's probably going to be always equal, but I put greater just in case. In that case, we can just say, okay, short circuit the entire execution and just like return out of that. I think that's a good solution. Otherwise, right, so otherwise, what we want to do, we want to actually remove that specific document from the entire thing before adding it back. Right, and returning that document is going to include not only removing it from docs, but also updating df. Right. I think this is actually reasonable, right? So probably want to remove that, and let's actually, yeah, there we go. That's a good solution, I think. Okay, so essentially, if we already have this in a cache and it's fresh enough, just don't do anything, just return. There is nothing to do here, literally nothing to do. Though we can try to ignore that document, right? We can try to ignore that document, and to make the entire recursive process that calls to the function ignore it, we have to return some sort of an error, right? So just by returning OK, we kind of screwing up with these stats about how many files were ignored. But maybe we want to have that. So I'm going to put a to-do on that, all right, to just like research what would be the best way to sort of update the skipped counter in here, right? This does not affect the skip counter in, what was the name of the function? Add folder to model, right? As you can see, we keep track of the skipped counter, right? So, and by just returning on K in this specific case, it's not going to update that counter. And maybe this is something that we want to update. I'm not really sure. So essentially, every time we encounter an error while recursively iterating through this entire stuff, we skip the file and continue, but also increment that skip counter. And then we display it at the end of the recursive thingy. So it's kind of a debatable whether I want to keep like update that in this specific case or not, but that's why I'm doing here. All right, so let me see if this is going to rebuild, recompile, and what do we have in here? The document is not a member of the model, and this is probably going to be a private to just in-memory model, but we'll have to do something like info in-memory model and just put it in here. I suppose that's what we have to do in here. Okay, that's cool. Remove the document. So, yeah. Let's do an experiment. I'm going to remove this entire stuff, right? And I'm going to try to reindex everything one more time, right? And while reindexing, it should not crash because we're adding the documents for the first time. The documents do not exist in a cache, so everything should go smoothly, right? And it went smoothly. And this is, by the way, the skip counter. So this is how we use the skipped file counter. We just bring it at the end of the entire recursive process. Right, and when I reindex that one more time, only then it should crash. No, it shouldn't crash. It should do that one more time. Because index subcommand literally removes the file and starts over. Okay, so to trigger that sort of error, what we have to do is essentially maybe create a separate subcommand, or maybe make the index subcommand also accept the second thing, right? So what's the usage for the index subcommand? So the usage is just like one file, right? So we also have this thing where whether we use the SQLite model or not, so yeah. So yeah, I'll probably have to update this entire stuff. So let me quickly make a small break, and after the break I'm gonna see how we can sort of trigger this crash where we try to reindex everything, right? So to do that, we'll have to have a situation when we read the index file again, right, and try to reindex with that file in mind. Maybe I'm gonna create like a separate reindex command, right? But that command will have to accept path to the folder. But maybe this is something that we should store in the model as well. Why not? Right? Maybe this is something that we should have in here, for instance. Right. Dir path, path buffer. Right. I think that makes a lot of sense, right? As we right, and then as we want to reindex something, we're gonna read the model, look at its dir path. Not sure. So this is not how I plan to use this kind of model in the end, so we're probably not gonna do that, right? Because the goal is gonna be never refer to any of the JSON files, always serve a folder, right? And what I want is that the serve subcommand should then look at the sibling files and find a file that would look like docs.jl.json or something like that, Right, so essentially the index is going to be the name of the folder plus like JSON or something like that. Maybe it's also going to have an index in here to indicate that it's an index for that specific folder. As we serve this folder, I would expect the application to just search for this file and read it from there. So yeah, or maybe it's going to be inside of this folder, but not particularly great idea because the folder might not have write permissions, right? So anyway, let's make a small break, and after that we'll see how we can implement the reindexing. So all right, let's continue. So let's go ahead and do the following thing. I think I'm gonna stick with reindex subcommand, right? But we're gonna accept the dir path, right? We're gonna accept only the dir path, and we're going to read the index.json if it's available. Kind of similar to serve. We even have search subcommand, but I'm not sure if it's actually useful. So it's like works without the web server, right? So maybe I'm going to remove it at some point. So here I'm just accepting the index path, right? And then I'm trying to read it. So maybe in here I'm going to simply hard code the index path, right? I'm going to hard code the index path, index.json, and I'm always going to try to read this entire thing. So I'm going to do it like that, serve. So what's going to be the next thing? So here, depending on whether we're using SQLite or not, we're reading either the model like SQLite model or the in-memory model. And use SQLite is actually set before any command. So that means we need to respect it in the reindex command. But I don't want to respect it, right? I don't really want to respect it because I'm going to remove the SQLite model anyway in the future. So I'm going to assert that we're not in this specific mode. The SQLite model is deprecated. Deprecated. There we go. Right. So let me find surf one more time, and I'm gonna only do the this thing. Right. I'm gonna only do this thing where I read the model from here, right? And similar to indexing, I'm going to be trying to do that, right? So add the folder to the model one more time, and then save it again, right? And then save it again. Reindex. So we're adding it to here. So, but we need to keep track of the skipped thingy. So we need to have a skipped stuff here as well. So we're gonna put it in here. And afterwards, we want to print how many files we have skipped. Okay, that all makes sense, right? So that effectively uses already existing model for reindexing. But in the index, we're using the default model here, right? We're just using the default model, which is kind of sus. Didn't we remove the default from in-memory? Oh, I see. So since doc is used as a value of hash map, it doesn't have to be default because the default hash map is empty. So you never have to initialize this entire thing. All right, that makes a lot of sense. I never thought about it. That's really funny. Okay, so that should be it, right? So let's try to recompile this entire thing. Just recompile without running. So what do we have in here? So we have an index file. It should be index path, in my opinion. Well, isn't index file essentially this thing? Yeah, I should use the index path to create index file. Right. We're gonna compile. Okay, so there's still some problems in here. Unused variable. Okay, so I'm gonna put this stuff in here. Doesn't matter. And the model is not mutable, so let's make it mutable, of course. Seems to be compiling, seems to be working fine. Okay, let's try to do index one more time, right? So let's do the index on this thing one more time, and it should be fine, right? Because we're not modifying an existing model. Cool. And let's try to do reindex. And it should crash on trying to remove a document. And it didn't, so there's something wrong here. That's very interesting. So how did it come to be like that? I have no idea. It's supposed to crash, but it didn't. So here we accept the thing. Here we read the model from index path, which is JSON. So that means something didn't work, and I'm not really sure what exactly didn't work. All right, so if I do something like println, reindexing, right, reindexing, maybe I can do something like assert false, right? Just want to make sure that I'm running the correct thing. Am I running the correct thing? Yeah, okay, I'm running the correct thing. Cool. So what we can have in here, I don't know. So we can do something like assert false. Assert false. The model contains this amount of documents, right? So, and we can say count is equal to model docs_len, right? So hopefully that will work. It's a private field. Okay, of course, Rust being Rust. Anyway, so declare it as private. It's public interface, private doc type. Oh my god. Calm down. Calm down. Just wasting my time. All right. Just recompiling everything. Cool. So it contains this amount of documents. So far so good. So far I don't see any problems. So maybe the problems are somewhere here, right? So maybe the problems are even in some of the other places. Wait a second. Everything's fine, actually. I think everything is fine because precisely because of not throwing an error, when we have to ignore the document. Because the entire recursive process just thinks, oh, we just handled that document that quickly. Right. So one of the things we can do in here, we can just do the logging, right? So we can do a warning, and then we can say that the file path is already indexed, right? So we can do something like this, right? So then we can do file path, and it has to be file path display, right? And in this specific case, we can return an error to let it know. Okay, so that's cool. Let me see. So what's gonna happen if we try to reindex this entire thing? That's very funny. So I forgot to remove the assert from there. Reindex, assert. We'll have to wait one more time. Okay. It's not saying anything. And then it exits abnormally. Why did it exit abnormally? All right, at least it said that, yeah, this thing is already indexed, and then it exits abnormally. That is really weird to me. That is extremely weird to me. I suppose this is because somewhere in the process, add folder to model, right? When we actually add, okay, that's very interesting. So essentially, when we can't add the document, we stop the entire process. And I wonder why. I wonder why we do that. So let me think. Let me think. So what other errors may happen when we add a document? What are the other errors? There's no potential errors in here, to be fair. I suppose the only reason we edit the result in here is for the SQLite model, because the SQLite model can error during adding the document because it interacts with external service. That makes sense. And if SQLite service fail for whatever reason, I suppose we don't want to continue iterating, because it's sort of like a, yeah, it's a problem with the model, so maybe we shouldn't try to keep throwing stuff into that model. So maybe that's the thing in here. So yeah, there are two possibilities. We can remove SQLite model and just make add document return some sort of a boolean. But who said we can't make it just return the boolean, right? Who said we can't do something like that? Right. We can do that, and that boolean will indicate that we added the document or ignored the document. So, and because of that, we can just do it like that. Okay, so let me go ahead and modify the trait. I think it's worth doing. So I'm going to go to the compilation errors and just like modify everything. Right, so what do we have in here? This has to be a boolean, right? So what are the other things? This one also has to be a boolean, right here. So we are in SQLite model, so in case of SQLite model, we're going to remove it anyway, we're also going to return true. Doesn't really matter. Here, on the other hand, we're going to return false, right? And so let's let the compiler tell me where we have to do the notification. Here is true. Okay, pretty straightforward. And it does compile, so that's a little bit sus. I don't want it to compile right away. So here, what we can do, if not, let's put it this way, edit, right? If not edit, we can do something like, so indexing, here we log that we indexing this thing. So here we're parsing this entire thing. So we always have to first parse. Ooh, this is actually a problem. This is actually a problem. Because we always parse the entire file even before looking into it. So, okay, that's a huge flaw. That's a huge flaw. So one of the things we probably have to do, we have to have an ability in the model itself to check, right, whether it makes sense to add the document or not. So essentially we need to have a function, something like requires reindexing, which is a really stupid name, but I cannot come up with anything else. And here we probably want to accept the path by a pointer, of course, and the last modified date. And this thing should answer us, right? It should answer us whether it's successful or not. And maybe it should also return a potential error for the models that interact with databases and whatnot, right? So we're trying to be a little bit more generic in here, right? Oh boy. So requires the reindexing is going to return true when true and false when false, nothing particularly special. So and the add document is always going to replace the document no matter what, right? Okay, let's go ahead and do that. So edit, so this is not what we want to do in here. So essentially what I want to do, model requires reindexing. I provide the file path, actually the pointer to the file path, and the last modified date. Right, if it's true, we render, parse everything, then we add the document, and that's it. Otherwise, we probably want to log something along the lines of how to say that? So maybe something like file path, ignoring file path, because we already indexed it. Okay, so that's good enough, I suppose. And file path is going to be file path display. You probably can't see what's going on behind my camera. I'm really sorry about that. Forgot to put something behind my camera. Okay. Cool. So display, and there we go. And maybe we should also increment the skipped in that specific case. Why not? Anything else? Okay, so for the SQLite model, so what do we need to do? Let's add this thing in here. And in that specific case, I think we're gonna just always return true, right? Because I'm gonna remove this model anyway, nobody cares. What else do we have? Model for in-memory. Okay. So, what do we have? And we're gonna move that entire condition, like this entire condition, to this thing. Right, it requires re-indexing. So, does it exist? It doesn't really have to be mutable, by the way. Does the document exist? Right. If it does exist, is it greater? Right. So, and essentially, we can do something like this. If this thing is less, that is insta-true. That is insta-true. Otherwise, it's also true. Right. So if the document does not exist within the model, it requires reindexing, right? If it does exist, but its last modified date is less than whatever we already witnessed, we also have to modify it. So in both cases here, it is true. We can be a little bit more fancy in here, I suppose. Right, so let me actually outline it like that. So we can map this entire stuff with something like this. Right. So now we have an option, right? We have an option that contains a boolean, right? We have an option that contains a boolean, and one of the things we want to do with that option is basically unwrap or true, right? Unwrap or true, but it's a little bit more complicated. Like, I don't want to be like trying to understand this functional sausage, right? So I think it's a little bit better. This one is a little bit better. Right, so document doesn't exist, so we add it. If it does exist but the last modification, we add it. Okay, so that's cool. So, and if we go back to the add document, we basically always have to remove the thing, right? So remove documents, always remove that thing, no matter what. We don't even need last modified date, right? Do we? I don't remember what it accepts. Yeah, it only accepts the file path, right? So we always remove this thing just in case. Right, and then we add it always. So here, the add document doesn't even need to return boolean anymore, so we'll have to go through all of that stuff. Right, so let's go. File path is not found in the scope. Okay, so let's call it file path then. So what is the other compilation errors? I cannot see. So this is not a boolean anymore. What else do we have? I can't see shit in dismissed. Okay, there we go. What else do we have? This one is just unit. What don't you like? So it's already path, so we don't have to do. We don't have to reference too many modifications. Okay, so this one's okay. This one's okay. What else? I don't see. So it's something about, what do you want from me? Do you want me to do just okay like this? Is that what you want? I think that's what it wanted. Model requires reindexing and it may fail, so we have to do question mark. All right, and we are reindexing. Hopefully it will finally fail. Please fail at already existing document. I beg you. Well, it should, yeah. So since we always call, okay, that's fine. Since we always call remove document, right? So first we checked whether we have to reindex it, and we don't have to reindex it, so we never actually call this thing. So what I'm trying to essentially do here, I'm trying it to fail at to do in remove document. That's what I'm trying to do. Right, like for the past half of an hour, I was trying to stir the execution towards this specific to do, so I can finally say, okay, let's finally implement this function, right? So this is how I usually work, right? So I outline what needs to be implemented and put like assertions in here, right? In case of Rust, it's to do, and I just drive the execution toward that part, so I can say, okay, so this is what we need to implement, and so on and so forth, right? I just keep driving the execution there, and it keeps escaping me, right? So I suppose one way to make it trigger is to go to the docs.jl, right? Find one of the files in here, and basically, I suppose, touch it, which effectively updates the date, right? As you can see, so all the other files in here are January 24th, and this is a March 26th, right? So I just touched that file, updated its last modification date, and this should trigger that specific assertion, hopefully. Please, yes, thank you very much. So we can finally jump in there. Right, so hopefully, let's actually do that manually because Emacs doesn't allow us to do that. And now we're ready to modify it. Finally, my God. Anyways, so yeah. So what we need to do, we need to find this specific file, right? We need to find this specific file. So we go to self docs, right? We go to self docs and get a mutable top by the file path, right? So something like this. If let some doc, right? Cool. If it doesn't exist, I suppose remove document basically should silently exit, right? We don't have such document in there. Okay, fine, we exit. If we do have such document in here, right? If we do have such document in here, one of the things we have to do is effectively. This one is interesting. What if we simply remove it? Right, every time we remove, I have a feeling that hash map should have remove function that is similar to insert. Insert returns the value when you replace it, right? And I suppose something like delete or remove should do the same thing. There you go. Called it, right? So it basically returns the value. So what we can do in here is essentially actually remove it, right? And if it didn't exist, right, if it didn't exist, it will return none, which will effectively like exit cleanly. And if it does exist, we have a document which we can iterate, right? So we have terms and frequencies. Specifically, we're probably interested, right? So we need to actually iterate TF, right? So we want to iterate TF and specifically the terms, right? So doc TF TF keys, right? Doc TF keys. Is it keys? Yeah, it is keys. And essentially, we need to go through all of the stuff in DF, right? Oh yeah, this one is kind of interesting. So we have to get a mutable frequency for that specific term, right? So and it can actually fail, right? It can actually fail, which is rather interesting. So if let some frequency, and we have to decrement it, right? Since we remove the document, so that specific term now occurs with -1 document, with less one document. How to say that? With one less document, with document -1. I don't know, speak English. Right, so that's pretty cool. And what's funny is that it should always be there, right? It should always be there. And if we can't find that, well, I mean, if we can't find that, we should probably also exit cleanly in here. I guess that's it. I guess that's the whole thing. Right, so we remove the document out of this thing. Right, if we found it, we iterate through the keys, and we remove all the individual keys from the df. Right, because how do we compute df? How do we compute df? Do we compute add document? So we compute df by iterating through the terms of that document, right? And then incrementing by 1. So, but here we actually do the full name in here. Instead of f, I would like to call it f. And also f. So I came to like a more or less stable terminology. By t, I usually mean term, and by f, I usually mean frequency. So since term and frequency occur very often in the source code, it's really clear what t means and f means in any particular context in here. Right, so that's why I just like use a single characters in here. Right. Okay, let's go ahead and just recompile this entire thing. So what do we have in here? It is not implemented, so maybe I don't have to do it like that. I don't know. I don't know what's up with that. So it's compiling. Hopefully it will just work, and I hope that it will reindex one additional file. Yeah, so it skipped majority of the files in here. That's actually kind of funny. So, and which file did we touch? All right, so indexing, yeah, well, I mean, So it's kind of funny. So we still try to index the files that we ignored before, and we know for sure that those files are not correct, right? So we indexed this one. Did we? I think that's the file we actually touched, right? So if we go there specifically, right? It didn't really allow us to go. Emacs has been hella annoying. I swear to God. Okay, so I just want to go there, please. So there was one. Was it? What was that? What was the name? ABS XHTML? I think that's the one we touched. Yeah, I think that's the one we touched. Yes. Okay, cool. So I guess we implemented this entire thing. So now we can quite easily just reindex the same thing over and over and over again without worrying that we're going to be spending like time on doing all that. That's cool. That is very, very cool. So what's going to be the next thing? What's going to be the next thing? We need to, I suppose, get rid of all of these commands like index, reindex, and stuff like that, and only leave serve. But I mean, I can do that a little bit later. So in the serve, we should also start looking for the index file. So here, in case of a serve, we just accept the index file, right? But we should accept a folder, right? We should accept the folder. And then start a separate thread where we reindex all of that. Okay, so I think I want to make a small break and make a cup of tea, right? And after the small break, I'm going to basically organize the separate thread that indexes everything. And in the main thread, we're going to have a web server, right? So we're going to have at least 2 threads. And I'm probably going to put the model somewhere in a mutex, in a shared reference. And we'll see how we can make the web server and the indexing process communicate with each other. Because I want to be able to serve the search results while the indexing is still happening, right? So that's kind of the goal, right? And so, and also in the future, right, in the future, we'll trigger reindexing every time you add new files or modify some files or some stuff like that, and it's only reindex those specific files. So that's going to be the goal. So the only thing that bothers me is that we're still trying to reindex the files that we know for sure are not, you know, the files that we support, right? So like not XML files and stuff like that. I don't know what to do with them, like in this specific case. Maybe we should add them to the model. Right. Maybe we should just add them to the model and keep their stats empty, right? So just like empty stats. Yeah, that's it. So that will prevent reindexing them over and over again. And at some point, maybe this file is going to be modified and it's going to become the file type that we support, and we'll effectively reindex it. Yeah. That's a good idea. So let me actually put a to-do about that. Let me put a to-do about that. Add folder to model, right? Add folder to model. And where is the error? Right, so when we parse entire file, yeah, there we go. So this is where we basically do that. We try to parse the file by extension. If we succeeded, we extract the content. If we didn't, we skip the file and just continue. Okay. Still add the skipped files to the model to prevent their reindexing in the future. Okay. All right. So let's make some break, and after the break, we're gonna try to create a separate thread. All right. So let's continue. Where is the serve subcommand? So in here, in the serve subcommand, we accept index path, but what we have to accept now is the directory path, right? So that's what we have to accept. Let's go ahead and do that. Dir path. Maybe I can steal some stuff from the index command. Right, so here's the dir path. There we go. No directory is provided. We probably also have to update the usage. Where is the usage defined? So index folder, yeah. So what we have to do is basically the folder and the address, right? So that's what I want to have in the future. So I suppose maybe in the future I'm not gonna have neither of these commands, right? So index and search, but maybe they could be useful. They could be useful as separate like standalone operations, to force indexing or something like that. So I'm gonna keep them just in case. So in here, here's the dir path. So the index path is going to compute it based on the dir path, right? So that's what we're gonna have. So assert false for now. And what I want to be able to do is to extract the file path. But to do that, I suppose I have to construct the path out of that. So let me see, if I take a look at the path, what kind of methods do I have in there? Do I have something like file name? I can already see file name. So let me actually go there. Here's the file name, and it returns the option, right? So because it may not exist, returns the final component of the file path if there is one. If the path is a normal file, this is the file name. If the path is of directory, this is the directory name. Okay, so that makes a lot of sense. So dir path, let's just go ahead and just do, maybe I can simply construct it like that, path new, like so. But maybe it's not going to work because it has to be path buffer, right? But we'll see. It has to be a point of some sort. Yeah, I think it has to be path buff. Right, path buff. So add the folder to directory. As you can see, we just do it like that. I'm not sure how to go about that for some reason. I'm really not sure. Okay, so index path. So here is the index path, and this is going to be path new dir path, path new dir path. And what was that? File name, right? File name, and it may fail. It may be option. So let's actually first print it. Just to see how it looks like. Right, so we're going to simply print this entire thing, index path. So path, where is that? Oh my god. Okay, so let me try to run and see. So we have to do serve, and we're going to be serving folder this time, not the index. So what are you saying? I cannot see. Option cannot be. Yeah, okay, so that means I have to use the debug output. Debug output. All right, so what we've got docs.jl. Perfect. So essentially, if I have any extra stuff in there, it's going to be cut off, hopefully. So what I want to construct now, I want to construct like a completely new file path, right? So that's what I want to do. But I don't really know how to do that. Path, so path buff, right? So I suppose it's usually done with path buff. And you can push additional stuff into this thing, and path P is just something like a path. Right, so you can construct it from here, and then you can push additional things. Pushing an absolute path replaces the existing path. Oh, okay, I see. But if you push relative, it just appends this entire thing. Oh, I see what's going on in here. But effectively what I want to have in here is just like additional index, additional extension. That's what I want to have in here, essentially. So if I'm going to have a file name, this is a little bit tricky. This is a little bit inconvenient. The fact that it might be missing is rather inconvenient. I really don't like this fact. Right, so for instance, I try to do it like that, and then OK or else, and I suppose what I have to do in here is just, you know, log some error of some sort. I don't know. Right, so directory does not have any. Okay, directory may not have any sibling, may not have an index file, because an index file has to be next to the folder on the same level as the folder, right, like this. And the name of the folder is missing in a case of a root. So you can't have anything on the same level as root, otherwise it's not a root. So we need to tell that to the user somehow, right? We need to tell the directory may not have an associated index file. Maybe we can say something like can't find index file for dir path. Right, so that's a reasonable thing to say, because if we're trying to index the root, there's literally no place we can save the index file for, because the index in our case has to be on the same level as the folder. You can't have anything on the same level as the root, because the root is above everything. Right, so I think that's a reasonable thing to say to the user in this specific case. Right, so, and the next thing we want to do in here, so we get, when we do file name, so let me go back to the file name, so path file name, it returns OSSTR, and effectively what I want to do, I want to use that oh man, this is so weird. It would be easier to just store the index inside of the folder, but then it messes up with the indexing process, so that's why I don't want to do that. Right, that's why I don't want to do that. Oh, it's so annoying, because now I have to get the directory of the directory. And it's just so finicky. I don't want to do that. It's so finicky. Oh my god. It's just like, no, I don't want to do that. Okay. Because I have to get the file name. Maybe I should just get like start. Right, so let's just spell out all of these annoying things that we need to have in here, right? And then maybe I'll be able to compress, right? So this is the file name, right? So it's more of a name, a directory name, right? So this is the directory name. That's what we have in here. And then we need to have a base of the directory, directory base, right? Something like that. So we'll have to do it like this. I'm gonna put it in here. Oh, it's so annoying when you have to work with so many like little small things, like. But I guess it's necessary to figure out what actually needs to be done. Right. So file prefix. What? What the fuck is a file prefix? Extract the file prefix. What? Foo. Oh. Oh, I see. I see. Into file path. Is there any easy way to just construct a file path by just appending an additional thing? I don't know. Is there like an easy way to do that? It's just, I want to have an easy way to just do that. Like, I don't want to be able to. I'm pretty sure there should be something. There must be something. Okay, where is the new? So it just accepts that. It's probably somewhere in the path buffer, right? Path buff. Like, it's there should be something to do exactly what I want to do, but it's so annoying. So what do we have in here? Reserve exact set. You can you can set extension. That's probably what I want to have. And it can fail, by the way, because like set extension is not going to work for root. That's for sure. Updates self extension returns false and does nothing if name is none. Okay, that makes sense. Okay, so let's go ahead and try to do that. But do I want to store? Yeah, okay. Index path. I'm going to put an underscore in here because we already have an index path in here, so it doesn't collide. I'm going to do path buffer new dir path, right? So, and I'm going to simply just do index path path underscore display. Just want to take a look at this entire stuff. Probably have to take it by a pointer or something like that, you know, the usual thing. Is not found. Okay, so do we have a path? So we need to have a path buffer. Okay, so it wants a string, it wants to like actually own this entire thing. Path buffer. Oh yeah, so you have to construct just that. Okay, so and then we push some stuff in there, right? So index path underscore, we're gonna push the dir path, which I hope we have to do by a reference, right? I cannot borrow a mutable. So maybe I should not do it. Okay, so this is what we got. Oh, and it's so annoying because it has a GL in here. Yikes. Okay. Set file name. Reserved exact. So if I try to set an extension, oh my god. Why am I... Why am I stuck on such a dumb thing? Like, it's always like that with Rust. Anyway, so index set extension. Extension. What I want to be able to do, I want to just be able to append like this kind of thing to here. And it's not going to work, right? I'm pretty sure it's going to do some stupid shit that I don't want to do. Yeah, well, it kind of did what I wanted to do. All right. So we're getting somewhere. Okay. Cool. But if I remove this slash, yeah. Cool. Okay. So that means somehow I have to explicitly tell this thing that this is a folder. I have to explicitly tell it that this is a folder, and I wonder how can I do that. If I just do push additional thing, like push a slash in here, just push a slash in here, it will think that I'm replacing it with an absolute path, and it's going to replace it, of course. All right, it's going to replace it. Why am I using release? It just wastes time. Let's not do release. It replaced it, of course. It replaced it. So can I just do dot slash to make it not replace it? It didn't matter. That is very cool. So if I just do something like this, okay, so it appended it, cool. And if I set the extension, it set this extension like that. The only way it works exactly as I expect it to work if there is an additional slash. Well, wait, it doesn't even work like that anymore. Ah, this is because I'm confused. Am I going crazy? I think I'm going crazy. Okay. So I guess I have to go a different route. I literally have to do the thing that I didn't want to do, like split this entire thing into file name and the base name, take the file name, modify it as a string, add extension, additional extension, then concatenate them back. Annoying. That's the only word I can use in here. Annoying. Okay, so, but I need to have this as a path. I cannot just construct this as a path because the expression doesn't live long enough. I just can't do it like that. Right. I just can't do it like that. The expression doesn't live long enough. Or does it live long enough? It seems to be living long enough. Right. How does it work then? That's very strange. But this is probably because I never tried to print this thing. Right. So I never tried to print this entire thing. So it doesn't live long enough, you tell me. Yeah. So temporary value dropped while borrowed. Classic. So that means I need to have this thing existing somewhere. Right. And then I need to refer to it as a path. Right. So I either have to constantly construct this thing like that. Dear path, file name. Alright, so this is gonna be name. You know what? I don't want to do this. I don't want to do this stupid shit. Honestly. I just don't want to do this stupid shit. So, you know what I'm gonna do? I'm gonna just hardcode index path to be that. Like, it's literally a waste of time to figure out that. Like, I don't care. Anyway, so I'm gonna put it to do, saying something like, figure out index path based on dir path. Right, it's just like I could do that, but it's just so boring. I don't want to do that because my goal is just to create a thread. Like, I don't want to be wasting time on this thing. I don't want to be wasting time on this thing. Okay, so this is how we're gonna go about all that. Okay, so index file, we opened the index file, right, and we're starting to, yeah, so we constructed a model out of that. But the index file may not exist, so we have to be careful with all of this. So is there any way to check if the file exists? Do we have a method that just, okay, so we can do path exists. That's cool. And if path points to an existed entity, warning this method may be error prone, consider try exist instead. So just panics. I see what's going on. So essentially, what we want to do, we want to simply use a default model if the file doesn't exist. So try exist. Did I already use std path? Yes. Try exists. Try exists. What? Oh, it has to be path. Yeah, path. New index path. Try exists. We want to do something like this. Exists. Map error. So error as return permission. Yeah, okay. Println error could not check the existence of file index path because of this stupid reason. Right, I'm gonna just do something like that. So one of the things I probably want to do, I want to define this thing in here. If exists, we're gonna try to open this entire thing, and we're going to assign this stuff like that. If it doesn't exist, right? If it doesn't exist, we're gonna assign maybe default thing in here, right? So let's see if this entire. Do I still have a certain there? No, I don't. Okay, that's pretty straightforward. Let me see if it compiles. Doesn't compile. No try. Is it in some sort of nightly path? Try exist. Oh, don't tell me that. Well, I mean, this is a local documentation. I should have that. It's a method path. Try exists. Oh yeah, I'm an idiot. So yeah. Okay, what do we have? So we're running already, so this is not what I want. Okay, cool. Finally, I have a model. And if I don't have a model, it still should work, right? So I can just remove the model and don't think about that anymore. All right, so it still works, so it doesn't really have any model. In fact, it's kind of fun to try it out. What if I just search for something? It doesn't have anything. That is fine. Right, it tried to search for something, but it can't find anything because the model is empty, right? The model is empty. Okay, so what's gonna be the next thing? We need to start the indexing process, but in a separate, oh God, a separate thread, in a separate thread. So the way we're gonna work with all of that, right? The way we're going to work with all of that, we're going to put that in arc, right? So essentially arc is a reference counter, right? But it's asynchronous one or atomic one. Yeah, A stands for atomic. So, and essentially that will allow us to share this specific thing among several threads, right? So we're sharing that among several threads. So then, but whatever you have in reference counter, reference counter reference. How do you even call this thing? It's a reference counter? What? Reference counter what? Reference counter reference? How do you call these things? A thread safe reference counting pointer. Okay. So, all right, whatever you have in a reference counting pointer, you can't modify that, right? So to make it modifiable, you have to put it behind one of these things like mutex or RW lock. So essentially RW lock, as far as I know, it just allows you to have multiple readers, but only single writer, right? So that's basically what it does. I'm not sure if we need RW lock right now, right? Because we're gonna always have either one reader or either one writer, which is equivalent of using just mutex, right? So and that's probably what we're gonna be doing in here. We're gonna be using just mutex. And in here, what I wanna do, I wanna do arc. New, I'm gonna wrap it like that, and then I also need to wrap it in a mutex, right? So it's gonna be something like this. And I wonder if just using default in here is gonna be enough, right? So we'll see. So let me try to compile this entire thing, and it's probably not gonna compile because we're passing a very unknown thing in here. Well, I mean, first of all, we have to have an arc, which is std sync and stuff like that. All right, so use std sync, and this is arc, right? So this is arc, and then mutex, and also part like mutex. Okay, so they're part of the same thing. They're part of the same thing. So what else do we have in here? God damn it, it's just like so annoying with these little warnings and shit. Okay, so let's not surf anything for now. So what do we have in here? Mismatched types. So yeah, I suppose it doesn't like this thing. So what we'll have to do is probably do a similar one. Arc new, mutex new, boom, boom. Is it going to work? No, it is not going to work. And this is primarily because I just have to put OK in here. Okay, it seems to be working. Cool. I'm really happy about that. Okay. So we need to start an indexing process, right? So we're probably going to do that in a separate thread. So we'll have to create a separate thread in here. Okay, so threads, as far as I know, you create them through thread spawn, right? Thread spawn, right? Spawn, and there are some examples in here. This is not a particularly great example. So we have to have a closure that moves everything inside. And one of the things we have to do, actually, we have to create a copy of this specific reference, right? Otherwise, we're only gonna move that specific reference into the thread, and we won't be able to use the same reference in another thread, like server stats. So we have to clone this entire thing in here. We have to clone it in here. There we go. So then we'll be able to use it in here. Okay. So now we need to find the add folder to the model, right? So this is basically what we want to be able to do in here, right? That's what we want to be able to do in here. But I suppose we'll have to modify add folder to the model to accept not really a dynamic pointer in here, but more of a like mutable. Can I just have something like this? Mutex and then arc. Will that work? That's a very good question. It's really dangerous because that will trigger a lot of other compilation errors down there, and I haven't finished with that thing yet. But maybe I did finish that, so maybe that's fine. All right, so undeclared thread. So where can we find thread? Is that std thread? Yeah, it's std thread. So let's actually put this thing here, std thread. So let's go through the rest of the stuff. So skipped, not found in the scope. Well, I mean, I'm not sure if I care, but I mean, I can provide in here. So what else do we have in here? Requires indexing, right? So requires indexing requires access to the model. Okay. What am I thinking? So how are we gonna log the entire document? So I suppose it makes sense to just like literally lock it like this, lock, and then unwrap it, right? So that locks the model up until the end of the iteration, right? Each iteration on each file, we're locking the model, and that is basically it. Yeah, that's reasonable, I think. We'll give it a try. Okay. And inside of this thing, we're passing it by... And that breaks reindexing. Right, that literally breaks reindexing, and it probably breaks indexing as well. Right, because now these things accept that stuff by arc and stuff like that. So maybe I'm gonna just comment it out temporarily, right, because I don't really know how to fix those subcommands. Right, how can you fix that? In fact, I may want to comment everything except surf. To be fair, like, we don't really need anything except surf, if you think about it. Right, so maybe that's fine. Okay, so it doesn't really have to be mutable. We can just pass it like this because it's a reference. And what else do we have in here? Okay, so this entire thing may fail at some point, right? It may fail. So what we're gonna do in this specific case, I have no idea, right? So maybe one of the things I want to do in here is just unwrap, right, and put it to do. What should we do in case indexing thread crashes? That's a very good question, right? So what do we do in that specific case? I have no idea. Okay, so add model to folder, so it doesn't like something about that. Use of a moved value model. How is that moved? I have no idea. So was it moved in here? Or where was it moved? I'm not quite sure, like, what do you mean by that? Okay, so let's see. Can I borrow model as mutable as it's doesn't have a copy. Value moved here in the previous iteration loop. Ah, we're literally moving it there. You can't copy it? Is that what you're saying? I mean, we can simply clone it ourselves. It's not that big of a deal. It's just a little bit weird. Right? Yeah, and every time we clone it, we just increment the reference counter. But it doesn't really make much sense in this specific setting, because this entire recursive process happens in a single thread. Though, in the future, we may try to parallelize this entire thing as well. Who said we can't do that? Yeah, so why not? So I'm gonna keep it as it is, and we'll see how it goes. Okay, so model as mutable, so I suppose that's what we wanna do, right? No way, it just worked. Fuck, that's so fucking cool. So we have some stuff that this thing is never used. Save model that JSON. Oh, okay, I see. By the way, I think we need to do save model as JSON here. So let me see how we do that. Save model as JSON, and yeah, we have to put it like that. And also unwrap. Right. So I suppose the same thread should you know, save the file, because why not? All right, so that's very interesting. So let me see what we can do. So save model. That kind of requires like locking this entire thing, but maybe we can do that. Why not just go ahead and lock it? Model model lock. All right, and also unwrap. We'll be able to do that. So borrow over moved model. So the problem is that I don't want to make this thing accept. Yeah, it's just like accepted by reference. Like, why do I have to do that exactly? So I just like don't want to do that. But man. Oh man, moved in here. And so what's wrong with here? What's up with that? I don't understand. I just locked it. Oh, I moved this stuff inside. Okay, I see. I see what you mean. Alright, it was moved inside. God damn it. So what does it mean? Does it mean I have to... Do I literally have to... Don't tell me that I have to do that. But it feels like I have to do that. But that also eliminates this thing, doesn't it? Yo, Rust is so bizarre. What the fuck? Okay, I see what it's kind of similar to how you in C++ you may pass shared PTR by a constant reference. Right, it's kind of similar to that. I feel like it is. Let's see. Okay, so here you want to do that, right? And then you want to do that. Okay, so what do we have in here? Expected found model. Expected reference model static, but it's not static, so it's not doesn't work the way I want it to work. Okay. I have an idea. Right. What if we clone it here? I'm probably doing everything wrong, right? So maybe it's going to be very inefficient, but I want this thing to at least work to some extent. Right. So is there anything interesting in arc clone that would tell us that, you know, how to use that? Makes a clone of clone. This creates another pointer to the same location, increasing this strong reference count. Which makes sense, I suppose. Right, but it kind of... Well, in this specific case, since we already cloned this entire thing, we can try to lock it in here. Right. I suppose that should make it. Can I finally do that? Okay. Expected trade object found in memory. Okay, so since I'm breaking everything, I might as well just be very specific about the model that I'm using. In memory model. I'm already super specific, so it doesn't matter. Okay, so it seems to be compiling. Right, finally. It is finally compiling, cool. All right. Okay, so now let's see if we can use... Oh, we can't use it. Okay, that's cool. It's fine. It's totally fine. And I suppose here we'll have to... Yeah, look at that. Look at that. So we make a clone. We just clone this entire thing and moved it inside, and we kept doing the clones. So that means we won't be able to just use this thing. Okay, so, and it's going to be a little bit painful because now in the server, we also have to accept, yeah, the model by arc, mutex, and probably have to be very specific about in-memory model. Right, so we probably have to be very specific in that regard. So, and that kind of like requires going through all of these things now. Right. So that means I also have to bring all of these things there as well. Okay. So thread is unused. Oh my god. So it's annoying how it puts all of these warnings at top while having more like higher priority errors at the bottom. It's just like, could you just put all of the warnings down there so I can get to them when I fix actual problems? That would have been great, I think. Don't you think? Okay, so server request. So here we probably have to also pass this kind of stuff like that. Right. So what else do we have in here? Model, server API search. That means we have to pass it there as well. Right, and we'll probably have to essentially clone that reference over and over again. Right. Arc. So search body method. Okay, so search query. Okay, so this is where we have to basically lock the model, right? So let's lock it. So I suppose it doesn't have to be mutable. So model lock unwrap. And let's just search, and hopefully that will do the trick. So stat and address. Okay, so SQL. Okay, so let's simply assert false. Assert that this thing is not SQL model. Right, so I don't want to have SQL model. It's just basically a sign that I have to finally remove it. right? So because it gets in my way all the time. So what's going to be the rest of the thing? Okay, so exactly what I said, it moves it, so we can't use it on the next iteration. So the reference was moved in there, so it can't be used. So I suppose we have to do arc clone every time in here. I'm not sure, is it a good idea to do these kind of clones all the time? Right, maybe it is not, I don't know. So mutable doesn't have... Again, it puts the unimportant warnings at the top, like I don't care, just like... It's just like, it doesn't matter, like why do you put them there? Like put them at the bottom. Right, put them at the bottom. It's just like when I'm gonna fix them when I'm done with the actual problems. I swear to God, Rust, it's just being annoying for the sake of being annoying. Okay, so here's the real problem that we have in here. Right, so I have a model in here, and I have to come up with a different name for this thing. Right. I mean, I can do something like this, I suppose. Not that big of a deal. Right. Okay, finally. Cool. Whew. Oh boy. So, there's a couple of things that are unused in here, just different warnings. I don't care about them. So, this is the moment of truth. Right. So now we are basically indexing and serving HTML at the same time. I'm a little bit afraid that the indexing is going to be too fast, so I won't be able to experience these things slowly being populated and stuff like that. So, but in any case, let's give it a try. So I'm going to just try to run it and see how it goes. Okay, so it's going relatively slowly, but at the same time, I'm able to like open this thing and then linear, right? So does it work? Received API, and it's just okay. Yeah, so it indices and searches at the same time. Interpolation, and it updates as it goes. It populates the entire thing as it goes. This is so cool. Holy shit. Yo, yes. And that's precisely what I wanted to achieve. That's precisely what I wanted to achieve. And yeah, so now maybe we can even deparallelize the entire process in here too. But I'm not sure how to do that because it's so recursive and stuff. We need some sort of a thread pool to do that. All right, and it's a bit slower than I would expect, and this is probably because, yeah, we are running a debug, right? So and then it saves this entire thing, and it keeps working, right? So it keeps working. So the next time I run this thing one more time, I hope it's going to be a bit faster, right? And as you can see, it's ignoring all of these things, right? And then it saves the final result. And I feel like, does it make sense to save it if we didn't... you know, if we didn't update anything? So I'll put a to-do about that in here. To-do, does it make sense to save the model if we didn't index anything new? Right, so this is additional to-do to think about. But apart from that, this works precisely as I expected it to work. This is so cool. Okay, so let me try to do that one more time. Of course, it's a little bit slow because, I mean, I'm doing debug, but I think in this specific case, debug is good because it slows it down, so I have an opportunity to actually test this thing in real time. So it's basically indices, and I can search at the same time and see how it goes. Right, so let's try to run it one more time and see how the thing populates. So as you can see, the results are changing constantly and nothing is related to linear interpolation. So it's, yeah, it's locking when it's actually indexing something big, right? It is locking when it's indexing something big, and this could be a problem, right? It locks for the entirety of the whole document, right? It locks for the entirety of the whole document, which is rather bad, I suppose. Maybe it should lock. Yeah, I'll think how we can reduce the amount of lockage in there. So there could be something done in here. Yeah, that's perfect. That is absolutely perfect. So there's also a lot of room for interesting additional features. For example, we can indicate the progress of indexing on the website itself. We can create another entry point that basically asks like how much is already indexed and how, like when it's going to finish, right? So we can estimate how many files we have in there and stuff like that. So yeah, so we're slowly moving towards like this multi-threaded architecture, right? And it's definitely now easier to use because you don't have to first index, then run serve. You can just run serve on that specific folder and you're good to go. That's it. You don't have to think about it. And if you add new files, something like that, it will reindex it again. It would be also kind of cool if it would like monitor the files within the folder and start reindexing only the things that modified and stuff like that. But there's a lot of ideas that could be implemented in here, right? There's a lot of ideas. But anyway, so I'm already doing that for almost 2 hours. So I think I implemented everything I wanted to implement. So yeah, that's it for the day. Thanks everyone who's watching me right now. I really appreciate that. Have a good one, and I see you on the next Azuzin session. I love you all. Mwah.